All right, folks, it's me, Mike, back again. The first video that we did was about the the control circuit, which is up here. This is the 24 volt DC. They're not always 24 volt DC on the control circuits. Typically, especially if you're in an older manufacturing facility, it'll just be 120 volt AC. Not very forgiving. It will let you know if you're not paying attention that you've touched something live. 24 volt DC is very forgiving. Your PPE requirements with 24 is completely different than what it is when you start messing with 120. So things to be considerate of. So we talked, I'm not going to go over this video, you can review it, but it talked about the voltages you're going to find and where you're going to find them. So now we're going to talk about the second one, which is we're talking about the next piece, which is the transformer here and the power supply. Okay, for the transformer, you are going to have 240 volts. Oh, excuse me. We're not going to have 240. If it's a 480 system, we'll have 400 volts VAC. If it's a 208, we'll have 208 on there. So pull them off of two legs, typically L1 and L3. We're going to have 480 volts. Whatever your three-phase power, that's what you're going to have on the primary side of that transformer. And you will have that at this location or this location, okay? This will be H1 and H2, okay? At a minimum. The next one that you're going to see on your secondary side of your transformer is going to be 120 volts AC, okay? And this is on the secondary side, which is this part over here, okay? And you're going to have those voltages. You're going to have it from here, which is going to be X1 and X2. X2 is going to be your neutral. So if you check from ground to the neutral, you should not get any, you shouldn't get any power, you shouldn't see any voltage in that. When you go from ground to L1 or, X1, or from your neutral to X1, you should see 120 volts AC, okay? On your power supply, on your input side, you'll see that 120 volts AC, okay? And on your output side, you'll see 24 volts DC, okay? And that should be at each one of your terminals. You're going to have a positive side, which I've got here, and a negative side. So if you go positive and negative, you should see 24 volts for you to be able to see that. If typically you're going to have circuit breakers that'll be on the transformer side, okay? You're also going to have a fuse in between each one of these processes, and I haven't drawn that up here, but you should have circuit breakers and you should have whatever overcurrent protection that you're going to need for that, whether it be a circuit breaker or whether it be a fuse, okay? When you're looking at this, again, the first thing that you want to look for is your safety relay. And do I say 4 green lights. Some of them have 3. Some can have many more, depending on some of these newer ones from Allen Bradley. There's like 5, 6, 7 green lights. But whatever it is, you need to have all of these green lights on. If they're not on, something, a safety device has been violated. And whether that safety device is a door interlock, a presence mat, a light curtain, an e-stop, any one of those things will cause those lights to not come on. And remember, the key ones is if you don't have this one here, which is your main power, Okay, that's telling you that that safety device is getting the 24 volts it's supposed to get, or the 120, it was a 120 volt circuit. And then this one down here is the power out. If that bottom green light is not on, you're not going to have any power that's up here. Okay? And typically, to make an adjustment on this, you're going to see in a drawing, you'll see a normally open contact, and it will be MSR and whatever the terminal numbers that are going to be on that. Okay, it can be an S21, it can be a S13, 14, whatever the case may be. But if this isn't on, then that's going to be open. When your safety device has been done, this will close and allow the 24 volts to go through your circuit. If this gets violated, it opens that and you get nothing in your control circuit. Okay? So the next thing is, if you go to these and you don't get any power, check those circuit breakers. These circuit breakers should be interconnected, so if one trips, they both trip. If they don't, you will have power on both sides of this, but you'll only be reading your phase to ground will give you 277 if this is a 480 system. Okay, make sure everybody understands that 480 is a 277 on the phase to ground on your check. All right, so we're going to get into some details on troubleshooting this, because transformers will give you some fits on certain things. But bottom line, if all your circuit breakers are right, you should be able to go from H1 to H2, and you should get whatever your system voltage is for the power circuit, 480 volts. Okay. On the secondary side, you should be able to go from the neutral to the from X1 to X2, and you should get your 120 volts. If you don't get your 120 volts, but you have power here and there's no fuses involved, then you probably got a transformer that's gone bad on you. Okay. Power supplies typically have a green status light. They don't all, but most of them will have a green status light. If that green status light is not on, that is not necessarily completely indicative that the power is gone, because those things don't ever trust a status light. Those things will fool you. They'll stay on when nothing's happening, and they'll go off when everything's working. So they're not completely trustworthy. But check your power. If you got 120 going in, you should have 24 volts going out. Sometimes you have a little potentiometer. Let's say you're getting 22. You can go in there and adjust that and tweak that to bring the voltage up to 24, where you need it to be. Okay. So that's where you should see your power or your voltage when you check it. You should see 24 volts going from here to here. You should see 120 volts going X1 to X2. You should see 480 going from H1 to H2. Okay. If you don't have those, check your overload protection, whether it be a circuit breaker or a fuse. And if those are good, you more than likely have a bad device and need to replace it. Okay. If there's any questions or anything like that, please give me a holler. Next video, we'll talk about the control circuit itself. We'll go into some details on that, and we'll do a separate video for that one right there. All right. So you guys have a good day, and always be safe.